Hello everyone and welcome back to another session in IBDP HLSL course, and in this session we are going to talk about the Voronoi diagrams and its applications, which is SL 3.6 topic. And in this session we will discuss sides, vertices, edge, cells, how to add a side to the existing Voronoi diagram, its applications like toxic waste dump problem and nearest neighborhood interpolation based problems. Okay, so let's start with the Voronoi diagram. So consider that there is a restaurant. Let's take Domino's example. Domino's have in a city. This is the map of a city. Have four shops in this city: A, B, C, and D. These four shops. Okay. So if a person calls them and asks to deliver pizza from this point, okay, that person is living at this point. So what do you think? We can deliver the pizza from any A, B, C, D, by the way, but for cost effective optimizing the cost, we can say it will be better if we deliver that object from the shop C. So, right, similarly, if a person is calling in this area here, what do you think? So we will find which shop is closest to that. So how can we do that? It's simple. You can draw the perpendicular bisectors. So if a person is calling, this is B and this is A point, consider these 2 points B and A. So this is the perpendicular bisector of these two, let's say. Okay. So if a person is calling from this portion, it will be better if A delivers that object, right? Because this perpendicular bisector is at equal distance from both A and B points, right? So in this way, we can use the Voronoi diagram. Now I will explain what is Voronoi diagram with the help of this example. See, same as these shops of Domino's, we have sides. We call those points as sides. As you can see here, these red dots represents the sides or shops in our case. Okay. Now let's call these A. This is B. This is C, D, and E. Consider only these five shops. So if a person is calling from this region, it will be better if D delivers that, right? How can we find that? We can find the perpendicular bisector. Actually, these lines are nothing but the perpendicular bisector. Like this one here is the perpendicular bisector of the CB. From the previous session, we have already seen how to find the equation of perpendicular bisector. Okay. Now, after that, next point is these edges meets at some point. So those points are called vertices. This point of intersection of perpendicular bisectors are called vertices. Okay. So now you know about the side. Now the edges, which are actually the perpendicular bisectors for us. And the point of intersection of those called vertex. Okay, and the most important, cell. Now what is cell? This region under that particular site is the cell for that. Okay, so if a person is calling from that particular site, it will be better if A delivers that packet. Okay, so this is called cell. In this way, see here, for this particular site, the area is infinite, right? There is no end at all. So in this case, it is not a finite cell, right? It's infinite. So like C is bounded by these edges. So yes, it is finite. Okay. Now, as I already discussed about the sides, cell, edges and vertices, always remember this thing that a vertex is always at an equal distance from all the adjacent sides. For example, consider this vertex. This vertex is actually at equal distance from all these three sides because this is the point of intersection of perpendicular bisectors of the 3 points. Like, okay. After that, we will discuss toxic waste dump problems also and nearest neighborhood interpolation. And remember, in your IBDP exam, generally basically the solution will lie on the vertex only. Okay, vertex of the Voronoi diagram. Okay, so we will discuss few real life based problems on this as well. Okay, let's move to The next, which is this question. It says in the Voronoi diagram given here, find the side which is closest to 30, 20. So you are looking for that side out of these A, B, C, D, E, F, G, S something. You have to look for that side which is closest to that point. So go to point 30, 20, right? On along X travel 30 distance, along Y travel 20 distance. So here is 30 and here it is 20. Yes, you can see it is lying in the cell of site A. So what's the answer? Yes, option A. Site A is the answer. That is the closest site to that point. Second part says give the coordinates of the vertex which is equidistant from the four sides. So for this, what you can do? You have to look for that uh, coordinate or that vertex which is the point of intersection of four edges. So look into the diagram and find out that point. Can you find that? Go to a point where it is a point of intersection of four edges. Okay, so can you find that? It is here. Let me mark the point here. Okay, so it is 20 and you can say 5. 20 comma 5 from the diagram we can see is the point of intersection of four edges, right? Third part, estimate the coordinates of the point equidistant to the side A, E and K. So go to the side A here, E here and K here. Okay, what is that point which is equal distance? So we will use the perpendicular bisectors of EK, AK and EA. So what is that point? This point is the answer. Okay, so in the graph you can easily find the okay, you can easily calculate the estimation for the point which is this vertex point, and in this case we are getting it close to x as say 19, right? And y value is around 25.5. Okay, so let me write the coordinates for that point which is coming out as in this case 19 and 25.5 by looking at this graph. Next part is explain why the diagram cannot give a point equidistant from C, F, I and L. Okay, so let's look into the diagram. C, F, I, L, go to that. Let me erase these. Okay, C, F, I, L. What are the points? And here is the C, F, I and L. Can you find a point which is at equal distance from all these? No, there is no such point, right? Because this cell B is lying in there. Because of this site B and its cell, you don't have any point here. Okay, otherwise that will be more close to B. Okay, so next part is part E. The point A comma A is equidistant from the side J and A N. So J and N, go to J and N here, J and N are here. Okay, so there is a point having both x and y coordinates same. It means that must lie on the line x equals to y. So what you can do? You can draw a line x equals to y or y equal to x. Yes, then you can find the point of intersection of that y equal to x with the with the perpendicular bisector of this J and M, right? So in this way you can get those coordinates. So approximate value, yes, you can also calculate the approximate value once you draw the graph for that y equal to x. It comes out as around, I'll say around 40 comma 40. Okay, it will be close to 40 comma 40 actually if you do this. If you draw the line, this is just an approximation again. So you can draw that line y equal to x. Okay, so 40 comma 40 is that point which is lying on y equal to x as well as on the perpendicular bisector of this j and n. Okay, next part. Next part says find the equation of the edge between the sides E having the coordinates 8 comma 28 and K 12 comma 18 in the y equal to mx plus c. Simple. We have to find the perpendicular bisector of these two. Okay. So we are already given E point which is having the coordinates 8, 28 and the coordinates of K which is 12, 18. So let's find the equation of perpendicular bisector of these two. So for finding the equation of perpendicular bisector, first we need to find the midpoint of these two. Okay, we have E and K, these two, and let's find the midpoint of these two. So what is that? Let's call it, give a name x. Okay, so the coordinates of x will be 12 plus 8 divided by 2, average of x. Similarly, average of y, 18 plus 28 divided by 2. That gives us 20 by 2 means 10, and it is 36 or 46. 46 by 2, 23. So this is the midpoint. Okay, 10, 23. Now let's find the equation of a line passing through 10, 23. And what about the slope? First, we need to find the slope of EK using the 2 points. So you can use 28 minus 18, difference of their y values, divided by difference of their x values, which is 8 minus 12. Okay, simplify it, you get 10 over 4 with a negative, means minus 5 by 2. So the slope of that perpendicular bisector line, this line which is perpendicular to it, must be negative reciprocal of that. So slope of perpendicular bisector of EK is equal to positive 2/5. Now you have the slope, also you have the point. So use the equation of line y minus y1 equals m 2/5 times x minus x1, which is 10. That's it. Now convert it in the y equal to mx plus c form and simplify it. So y is equal to 2/5 of x minus, it is 4 plus 23. Okay. So what is that? It is the answer. Just simplify it. We will get 19 here. So 2/5 x. So the final answer for this part is y equals 2/5 of x plus 19. That's my final answer. Okay. So in this way you can solve these problems. I hope you got all these. Still, if you have any doubt, you can ask me anytime. Okay. Let's discuss the largest empty circle, or which we also call toxic waste dump problem. Okay. So what we are trying to do in these cases, for example, suppose that a restaurant is looking for a new location within a city. They might be interested to see which location is farthest from all the competing restaurant as well as in the city. Okay, so we can use the Voronoi diagram. Okay, and we can find that largest empty circle, and the center of that largest empty circle will be our solution for that work. Okay, so for example, this is the diagram, Voronoi diagram, for sides, edges, vertices, everything is given, and we are trying to find, we are trying to add one more cell to it, right? And we are looking for largest empty circle over here, as you can see here, and the center of that can be our new site. Okay, we are trying to find the largest empty circle, and as I said earlier also, that the center will lie on the vertices for IBDP. Okay, so this is the largest empty circle, you can say, and its center will be our answer. So let's discuss a problem on this as well. Consider this situation, and we have to find the coordinates of the center and radius of the largest empty circle. Okay, so A, B, C, and D, these are the given sides. Okay, four sides are there, and we are looking to find the largest empty circle over here, and we know that center must lie on edges. So here we have this point, let's call it E, and this point, let's call it F. E and F. So center must lie on any of these. Okay. One thing is, by looking at this diagram also, we can directly say ki which one is our answer. Okay. Like we have one circle as over here, and another circle is this one. Something like this. So which one is greater? It's obvious, right? But okay, let's do it with numerical values. So here we, what we can do is we can find the distances of these points E from its closest side and distance of F from its closest side. So either you calculate EA or EB or EC, all are same. You can use the distance formula, right? What are the coordinates of E? It is 4, comma 3 for E. And similarly for F, you can find FB, FD or FC. All are same. Okay, so let's use EC and FC. Okay, so if you use EC and FC and use the distance formula, right, you will, you can try it. Okay, you will end up getting answer as, for the first part it is this one, root 13, and for the second one it is root 25, or you can say 5. So which one is larger? This point is larger, right? So as we can see here, this point which is having the coordinates around 10 comma 3 is the center of the largest empty circle, and its radius is what? That 5 units. That's the answer. So in your IBDP exam, you can always use the vertices of the Voronoi diagram to, and you can find the distances to check which one is farthest from all the other. Okay, that's the answer. Next part. For the Voronoi diagram shown below, you have to identify the following things like sites. What are the sites over here? As you can see, sites are these shops. Okay, so here I have A, B, C, D, E. These are 5 sites over here. Vertices. Now you have to mention the vertices. So vertices are points of intersection of these perpendicular bisectors. This point, basically these P, Q, R, S, T are the vertices. Okay. Next is finite edges. Remember, finite edges. So find those edges which have both initial and terminal point, means segments. So finite edges are what? P, T, yes, T, S, and P, Q, T, Q, Q, R, and R, S. As you can see, these are the finite edges. Okay. Finite cell. What are the cells that are finite? So this cell contained by side D and E are the finite cell. Otherwise, A, B, C are infinite cells, right? Cells containing A, B, C sides are infinite. So for the finite cell, we have only D and E. Answer. This question. The function has the following values at these sides. A, B, C, D, E, like temperatures are given to us. Okay. Use the nearest neighborhood interpolation to estimate the value of the function at 5, 4. So go to point 5, 4. X4, 5, Y4 lies over here. So nearest side is A. So whatever be the value at A will be the value at that point. So at 8 is 12. So answer is 12 only. Okay. One more question. It says the diagram shows the map of an island and with the transmission towers at A, B, C. A Voronoi diagram A, B, C is already constructed over here. Then it says a Voronoi diagram ABC has been constructed to show the area which is the closest to the all the 3 towers. So if fourth tower D then added at point 6, 10. So here we added the new point. New site is added at 6, 10. Perpendicular bisectors are also given to us already. Now it says write down the equation of the perpendicular bisector DB. So I already told you how can we find the equation of perpendicular bisector. We have the coordinates of D. Yes, we also have the coordinates of C given already. So can you use this? Okay, I'm leaving this question for you, right? You can use these 2 points and find the equation of perpendicular bisector for that. B part says complete the Voronoi diagram. Same as previous, if you have to add this D side, okay, now you have to find what will be the new diagram corresponding to this. And remember, perpendicular bisectors are already given to us here also. Okay, so you can draw the perpendicular bisector. After completing this Voronoi diagram, you have to check if a receiver is at a point 10, 4, then from that Voronoi diagram, you have to check which point is closest, right, to that 10, 4. find out that. Okay, 10 comma 4 will be a point over here, and you have to check after completing that new Voronoi diagram. Okay, so you can try out this question by yourself. Okay, and if you find any doubt or anything in it, you can ask me anytime. Okay? So this is your homework question. Okay, so now we have covered the following things today. I started with defining the side, vertices, edges, and Voronoi diagrams. Using the incremental algorithm to add a side, yes, we did this, and nearest neighborhood interpolation, and also the toxic waste dump problem. We have covered everything. Okay, so that's it for this session. I hope you got all this. If you want to ask anything, feel free to connect with me. Thank you for watching this. Keep watching, keep learning.